Dear students, I am Kumar, a lecturer in chemistry, working as Dear students, I am Kumar, a lecturer in chemistry, working as an executive dean in Sri Chaitanya Educational Institutions. Today, we are learning how to do chemistry practicals and lab etiquette and the precautionary measures that we need to take during the preparation and also during the practicals. In general, chemistry practicals consists of 4 parts. One is qualitative analysis, volumetric analysis, identification of functional group in the given organic compound, and viva and record. For qualitative analysis, 10 marks will be awarded, and for volumetric analysis, 11 marks, and for our identification of functional group in the organic compound, it is 4 marks, and for viva and record, it is 5 marks. This is the division of marks in the chemistry practicals. The way you do the practicals in your laboratory is different from the way we do practicals on the examination day, because in the laboratory one day you will be doing qualitative analysis, and the other day volumetric analysis experiments, and on some other day identification of functional group. But in the examination, all the 3 practicals you need to do on the same day, that is on the examination day. So because of that, the lab etiquette during the examination is a bit different from the lab etiquette in our regular days. So in the examination, after entering into the examination hall, the external examiner will ask you to take an additional sheet on which some number will be written. That number is nothing but your table number or your position on that examination day. After that, examiner will ask you to copy a volumetric analysis question which is written either on the blackboard or that question will be dictated. And in that, volumetric analysis question will be given to you. You need to write the procedure of that experiment in the first 10 minutes. So we need to see what are the contents in that procedure. In that, the first one is nothing but question itself, and after that, apparatus. Normally in any volumetric analysis experiment, we use burette stand, pipette, conical flask. These are the apparatus which we use in the laboratory, in the volumetric analysis experiment. And the next part is a principle. In the case of a principle, we need to write the reaction between the 2 substances that will be given in the volumetric analysis experiment. In general, there are 42 experiments are there in the volumetric analysis, but all the 42 experiments or all the 42 questions are involved the same procedure and same method of doing the experiment. Here we have the 2 kinds of titrations. One is acid-base titrations, and the number 2 is Permanganometry titration, that is called the redox reactions. In the acid-base titrations, there are 2 bases. One is the sodium hydroxide, another is sodium carbonate, and 2 acids. One is the HCl and sulfuric acid. Among these 4 combinations, for the nearly 30 questions will be generated. For all the 30 questions, procedure is the same thing. So after writing the question on the additional sheet and after writing that apparatus, then principle. Principle means you need to write the reaction between the 2 substances that are given. And after that, indicator we need to mention. This is the very important point. For all acid-base titrations, we use methyl orange as an indicator. So there we need to write methyl orange as an indicator. In case of permanganometry, as potassium permanganate itself has a color, no external indicator is used in permanganometry because the potassium permanganate acts as a self-indicator. Then, after mentioning this principle, then we need, after mentioning that indicator, then we need to write a procedure part. We must write a procedure very briefly. That is, in the procedure, what we take in the burette, and by using pipette, what chemical is taken into conical flask, and what indicator we need to add, and what color we get to the solution present in the conical flask after adding indicator, and what is the color change at the end part. Only these points you need to mention in that procedure part. And after that, tabular form. And after the tabular form, we need to write the formula, that is M1 V1 by N1 is equal to M2 V2 by N2. With this, procedure part will be completed. After the completion of this procedure, this additional sheet that external examiner will take, and the main answer booklet will be given to you. And you can start either volumetric analysis experiment or qualitative analysis experiment. First, let us see volumetric experiment. Now, in the first experiment, let us see sodium hydroxide and sulfuric acid. And in the volumetric analysis experiment, we use a pipette, burette stand, conical flask. Now, this is the pipette. This is a 20 milliliters calibrated pipette. Now, every pipette will have an etched mark. If you take the solution till that etched mark, that is sufficient. There is no need for me to take the solution into the pipette till the top. So now I am doing an experiment between the sodium hydroxide and sulfuric acid. Now sodium hydroxide, a solution will be given to us, and that sodium hydroxide I am pipetting out.
Ready, start.
Now this is 20 milliliters of sodium hydroxide. I am dropping that 20 milliliters of sodium hydroxide into a conical flask. This is the conical flask. And don't try to blow out the last drop that is present in the pipette. Now after that, I am adding 1 drop of methyl orange indicator. Now after adding that methyl orange indicator, the solution present in the conical flask changed to yellow color. And now we can enter it. Burette, it is 50 ml burette. And in all acid base titrations, acid should be taken in the burette, and now I have taken 50 milliliters. That means this is burette. Again, a burette will have an etched mark, and if you take that acid till this, it is equivalent to 50 milliliters. And the most important thing is, this is the nozzle part of the burette, and in this nozzle part, air bubbles should not present. Now, what I am doing is, already I have taken 20 milliliters of sodium hydroxide into the conical flask, and a drop of methyl orange is added. Now the solution is in the yellow color. Now always hold this conical flask by using these 3 fingers of the right hand. Then hold the burette with the left hand like this, and then slowly add the sodium hydroxide, the sulfuric acid, which is present in the burette to the sodium hydroxide. Now this experiment should be done very, very slowly because 5 marks will be allotted to the reading part. And if ever we get some wrong reading, the marks will be deducted proportionately. So because of that, do this experiment very, very slowly. So now I am adding sulfuric acid. And at the end point means the point of complete neutralization, the solution present in the conical flask will change its color from yellow to light pink. Now that's it. We got a wonderful light pink color. And now we need to stop the experiment. Then we need to see the reading. Now the reading here is 14 milliliters. And for colorless solutions, always we must see the lower meniscus, and for colored solutions, that top level we need to see. Now initially the reading is 0. Now at the end point the reading is 14. That means 14 milliliters of sulfuric acid is used up for the complete neutralization of 20 milliliters of sodium hydroxide. And then after we need to discard the contents of this conical flask. Again we need to repeat the experiment. Now in the case of first experiment you got 14 milliliters. That means most probably your reading will be around 14. So while doing the second experiment, again pipette out 20 milliliters of sodium hydroxide into the conical flask, add 1 drop of indicator, then again do the same experiment. Now for the next time, that initial value, initial burette reading is 14 milliliters. Now do the experiment. And again at the end point, it may be around some 28 letters or so. So initial reading is 14. Final reading is 28. Again 14 milliliters of sulfuric acid is consumed. So like this we need to do the experiment at least 3 times or 4 times. Or we need to do the volumetric analysis experiment till 2 consecutive readings must coincide. And these readings must be entered into the tabular form which you need to mention in the main answer booklet. Now let us demonstrate one Permanganometry experiment. Now it is nothing but estimation of Mohr's salt by using potassium permanganate solution. In the Permanganometric experiment, we need to take potassium permanganate in the burette, then Mohr's salt or oxalic acid, because these are the 2 chemicals which we use. So either of these, that means the question that is given in the examination, basing on that, either of them should be taken into the conical flask by using pipette. Now we are doing estimation of Mohr's salt by using potassium permanganate. Now I am pipetting out 20 milliliters. I am pipetting out 20 milliliters of Mohr's salt. Now I am taking this Mohr's salt into the conical flask. Now this Permanganometric experiment should be done in acidic medium. So I am adding nearly 20 milliliters of sulfuric acid. Instead of 20, even if you take a bit more or bit less, it does not make any difference to that actual reading. So here in Permanganometric experiment, no external indicator is used because the potassium permanganate acts as a self-indicator. Now this conical flask contains Mohr's salt plus sulfuric acid. We added sulfuric acid because we are doing the experiment in the presence of acidic medium. Now I am adding this potassium permanganate to Mohr's salt. We need to add this potassium permanganate to Mohr's salt till the solution present in the conical flask turns to pale pink. And initially this potassium permanganate is to be added very slowly. Now I am doing the experiment. So always we must do this titration like this only, that is by holding this conical flask with right hand and that burette stopper with left hand, and our eyes must look for that pale pink color to the solution present in the conical flask. Now beautiful pale pink color we got in this experiment. Now note down that burette reading. This is nothing but the final reading in the first experiment, and the initial reading will be 0. Difference is nothing but volume of potassium permanganate used up in neutralizing 20 milliliters of mole salt that is taken in the conical flask. Now we got that end point. And after noting down this reading or the volume of potassium permanganate consumed, then it is to be discarded. And again, we need to do the experiment 2 or 3 more times till 2 consecutive readings coincide. After getting the 2 consecutive readings same, and those values should be written in the main answer booklet. And after that, again we need to write the formula, that is M1 V1 by N1 is equal to M2 V2 by N2. Then among the potassium permanganate and mole salt, let us take mole salt as a 1 and potassium permanganate as a 2. M1 is nothing but molarity of the mole salt which we are finding out in this experiment. V1, volume of mole salt, that is nothing but 20 milliliters. While taking the volume of mole salt, don't consider the H2SO4 which we have added. Consider only the volume of mole salt. N1, number of moles of mole salt, that is 10. Similarly, second is nothing but potassium permanganate. M2, molarity of potassium permanganate, that will be given to us by the external examiner in the form of a question. Then V2 is nothing but volume of potassium permanganate. By using this burette reading is nothing but volume of potassium permanganate, and the number of moles of potassium permanganate, that is nothing but 2. And by using formula M1 V1 by N1 is equal to M2 V2 by N2. Now we have all the values, so except M1, and that M1 we need to determine. After the determination of M1, based on the question given, we need to find out the weight of Mohr's salt in this experiment in the given volume of potassium, the given volume of Mohr's salt. So indication of a functional group in the given organic compound. So after this qualitative analysis and volumetric analysis, then is identification of functional group in the given organic compound. So some organic compound will be given to you, then you need to identify the functional group present in it and you need to confirm it. In this, the first part is physical state. There are only 2 states here, one is solid, another is the liquid. So among the 10 organic compounds that are in the syllabus, 3 are in the solid state. They are glucose, fructose and benzoic acid. 7 are in the liquid state. They are ethyl alcohol, phenol, acetaldehyde, acetone, aniline, and benzaldehyde. So, in the physical state, just mention whether the given substance is solid or liquid by looking into that. After that physical state, the next is the color. Except phenol and aniline, all the remaining are colorless. For phenol, it is a pink color, pale pink color, and for aniline, it is a brown color. Then color, just write what color you observed by looking at the salt. The next is ignition test. In the case of ignition test, take a small quantity of the salt, that is a given substance, either salt or liquid, into a spatula and heat it. If ever you get a sooty flame, then the given compound is an aromatic compound. If ever non-sooty flame is observed, then the given compound is an aliphatic compound. If ever a burning sugar smell is observed, then it may be a carbohydrate. So in the ignition test, these three changes may present. So for physical state, half mark, and for ignition test, half mark, and then for solubility, then take the given substance, add water. If it is dissolved, then write it soluble in the water. If ever it is soluble in the water, it may be ethyl alcohol, acetaldehyde, acetone, acetic acid, glucose, or fructose. Then you just mention that whether the given salt is soluble in the water or not. If it is insoluble in the water, then test its solubility with sodium hydroxide. If it is soluble in the sodium hydroxide, they mention that the given substance is dissolved in the sodium hydroxide. If it is soluble in the sodium hydroxide, it may be a phenol or it may be a benzoic acid. Then, if it is insoluble in the sodium hydroxide, then dilute HCl. If ever it is soluble in the dilute HCl, let us mention the same thing. Then it may be aniline. Then it may be dissolved or may be soluble in the concentrated sulfuric acid. If it is soluble in the concentrated sulfuric acid, then it may be benzaldehyde. Then in the action of in the solubility test, we need to mention whether the given substance is soluble, that substance is dissolved in either water or sodium hydroxide or HCl or sulfuric acid. Just we need to mention that. And for solubility, 1 mark will be awarded. After physical state, color, ignition test, and solubility, the next part in the organic salt is identification of functional group. So first of all, we need to do action of this sodium bicarbonate. Take the given salt, add sodium bicarbonate. Quick effervescence may be observed. If the quick effervescence is observed, then carboxylic acid functional group may present. We need to mention there. Then, if no change is observed, that means quick effervescence is not observed, then carboxylic acid functional group is absent. Then alcohol may present. If ever quick effervescence is observed, there we have written that a carboxylic acid